any questions about what we talked about last time, namely the difference between primitive variable types and object references? There was something I seemed to forget last time, and I'm trying to think what it is. Oh, what happens when you compare things? All right. If you compare object references, if you compare primitives, it just looks at the value and sees if the values are equal. If you compare object references, it looks to see if both the variables are pointing to the same object, which is different. All right. There could be two student objects created and both of them be for Mike Zeller. But if it's two separate objects that I compared the variables, it would tell me that they were not equal. That's why with strings, and strings are also an object, you use dot equals. All right. If you want to compare a string, you use dot equals. And if you want to compare other objects that you create, you can write your own dot equals method that will see if two objects are equal. I did want to mention that before we continue. Are there any other questions? No one had questions before. Yes. You would do whatever made sense for the particular object that was. So for example, and these are just examples off the top of my head, so they might not be perfect. If I wanted to compare students, a student object to another student object, I might want to look to see if their student numbers were the same, because student numbers identify a student. So that might be the only check that I would want to do. If I would want to compare pizzas and see if they're the same, I would probably compare the size, whether they have pepperoni or not, and the crust type, using the pizza example I had. So it would be a string of if statements. Yeah, some sort of if statement. So you do whatever makes sense for your particular thing. It could be a simple if statement. It could be a chain of if statements to compare it. Repeat that, please. Yeah, absolutely. That wouldn't really be an overload function. That would be overriding the function. All right, because generically, I believe on object there is a dot equals method all the way back to the ancestors, but you could call the dot, you could make your own equals method. I think you would be overriding. I'd have to look it up to see for sure. This is something that you should probably get used to reading. The definitions of classes on the official Java site, Oracle. And they're a little hard to read. It shows you where they're found and what package. It says if there is any, things that it inherits from, and we'll talk about inheritance later. And it says how many creation constructors there are, and it says what the methods are. So there actually is no equals method on objects. So yeah, you wouldn't be overriding, you'd just be creating a new function. All right. What I want to talk about today, and what I want to spend most of the time talking today about, is array lists. And so we'll spend a little bit of time just talking about them, and then we'll see an example of them put into use. So we already talked about arrays. Briefly, we talked about arrays. The very first assignment you had to create an array for the list of words that you want to substitute in your mad lib. All right, then use the random number to pick the thing that you wanted. So we solved at the very least how to create an array and how to use it. Let's look at this tutorial. An array, the syntax of an array, creating an array is simply the type of object that's going to be in the array or primitive that's in the array. You can put primitives and objects in an array. All right. And then you have, if you have empty braces, all right, you're going to have to, at some point, define the size of it. So how do you define the size of an array? One way is by giving it a list of values. And this is what I think most, if not all of you did for the homework assignment. You said you had an array of strings, and you named it cars or whatever, and then you had values separated by commas. Ints would be the same way. You could create an array of integers. So it can work on primitives or object references. How do I access the member of the array? I simply say the name of the array, and then in square brackets, I use the position of it. And the position of it, of course, starts with 0. So Volvo is car sub 0, car sub 1, sub 2, sub 3. I can set the value of an array element that way. So I could initialize it as Volvo, but change it to Opel. There is a length attribute that I can use to determine how many elements are in the array. Some of you used this in generating a random number, and that was great. Good job. Because that means all you'd have to do to change your program is add something to the array. All right. So if your array was initialized with 4 things, you added a 5th thing, you would not have to change anything else in your program. If you hard-coded like the size of the array, like 4, well, when you added something to the array, you'd have to remember to go and change that value too. It doesn't show here, but the other thing you can do is you can declare the size of an array right as when you make the array. So I can also do this. Word is not the best thing to do this in. That would create an array of 3 integers. Trying to look for an example here. Oh, equals, I'm sorry. I was suspicious I was doing that wrong. That's why I double checked that. So I could say looks equals, or x equals, new int 30. All right, now create an array that has 30 positions. Now, some of those positions are going to have the default value in, and the default value of an integer is 0. The default value, if I made this a string, however, there is no default value for a string. I do not want to type string there. Like that. All right. If you create an array of strings or any object, they do not get a default value, which means they are null pointers. So if I tried to do something like this, I would get an error because x sub 0 points to nothing. Whereas if this was an integer, if I did that, it would print the default values for integer, which is 0. All right. There's probably more time than I should spend on arrays because there's something better than arrays. And there's something that most of the time you're going to use this instead of arrays, and that is an array list. Okay? So the reason I say it's better is that array lists do everything an array does and more. Okay? So why do one but the other? Why do we even have arrays then? Well, strictly speaking, arrays take less memory than array lists. So if you really had a program with like gigantic things in it, gigantic pieces of data in it, maybe you'd use an array, despite its drawbacks. But under normal circumstances, you're going to be using an array list. So pretty much everything in this class, you'd be using array lists from now on. It would be a very rare exception. One restriction of an array is that when you make it a certain size, it stays that size. Can't do anything about it. So if we say this, there's 3 positions in that array, and there will always be 3 positions in that array. Or if I say this, that also fixes the size at 3. There'll never be a 4th element in that array. Well, there might be some things that's good for. But again, for most things are more dynamic. Think about all the things that you might run into in a real application. If you're a student, you're going to enroll in classes. How many classes are you enrolled in? I don't know. You might be enrolled in 1, you might be enrolled in 5, let's say. All right, so there's a variable number of classes that a given student would be enrolled in. If you are a professor, you might teach 1 class, or you might teach 8 classes or whatever. All right, if you place an order from Amazon, you might order 1 item, you might order 5 items. Right? Almost anything that you can think of, there is a benefit to not fixing the size of the list. So therefore, it's typically going to be better to have an array list. So let's see what's different about array lists. And let's see how to do the same thing in array list that we do with arrays. All right, definition here, it's a resizable array, which can be found in the Java util package. All right, we'll look at the implication of that in a minute. The built-in is the size of the array can be modified. When you declare a array list in your program, you must import this package and class first. So you put that in. That simply is clarification to the compiler what kind of array list you're talking about. Now, here's like something that I would never suggest doing in a million years, but you actually could do. I could make my own class called ArrayList. All right. And I could put it in its own package, in which case I might want to use my array list instead of the standard Java array. I would never do that because that would be really confusing. All right. But I could do that. That's what the import does. It says what version or where can I find the array list that you're using as array list in this particular program. Okay, first thing is this different between declaring an array list and declaring an array is the syntax. We say it's an array list, and then we have in these triangle brackets, or the less than and greater than sign, the type of data that's going to be in. So array list string means that this is going to be an array list that contains strings. All right. You define what you're putting in the array list, the type of data that you're putting in. And then you say equals new array list, and then you repeat string. You can also omit the string, and it works too. So that's how you create an array list. How many data, how big is that array list? Initially, there's no value there. All right, so there are 0 strings in that array list right now. Okay. So how do I refer to elements in the array list? First of all, let's look at how we add elements to the array list. We add elements to the array list with a .add statement. That's a function. I say the name of the array list, .add, and then in parentheses, I have what it is I want to add. So this adds the first array list element, which is sub 0, sub 1, sub 2, and sub 3. Okay. So this array list, after I executed this code, would contain 4 elements. W3 Schools is a pretty good reference. It's not necessarily the best reference out there, but what I like is the simplicity of it. And the other thing I like is I can try it myself. So if I go and run this, it shows me the result. Okay. So that is the array list. If I get rid of this and run it, it'll show me the 3 elements. All right? So that's kind of cool. It's a good way to get to know how a certain class works. How do I access an item? You access the item by using the get method. So in an array list, if I wanted the 0th item, all right, let's say I have an array list. It contains strings. And for shorthand, you can just do this. if I say names.add now, if I wanted to access that element, I would say names.get sub-0. So I could say string n equals name sub-0, except the syntax for sub-0 is by using the get method. So remember, in an array, you would just say names sub-0. All right. You don't use that syntax with array lists. So this is for arrays. If I want to change an item, I use a set method. So in an array, I would say names sub-0 equals some value. The equivalent for an array list would be something like this. So that sets the 0 element to George. There'll be functions for everything that you do in an array list and everything that you want to do. How do I remove an item? Which is a nice feature to have, because let's say you placed an order, or we're placing an order, and you added 3 items to your order. Then you think back and decide, well, I don't want that second item. Let me delete it. If you did that with an array, you'd have a null object smack dab in the middle of the array, right? Because remember, an array never changes sizes. So if you declared for 3 elements, that array is going to be 3 elements long forever. And if there's no value in there, then it's going to be, and as an object reference, it's going to be null. So what we do to remove an element is the remove function. So this, we create an array list that contains Volvo, BMW, Ford, Mazda, and remove the 0th element. This now becomes the 0th element. This becomes element 1, and this becomes element 2. So if I run this, BMW gets position 0, Ford gets position 1, and Mazda gets position 2. And that happens automatically. If you remove something, you can just get rid of it out of the array, and it adjusts the size of the array list. You can get rid of everything by using clear. You can determine the size of an array list by saying dot size. Okay? That's different than an array. An array, it's dot length. And with an array also, it is not a function, it's an attribute. With an array list, size is a method. It's a function. Therefore, you need the braces after it if you're going to do it. So this should say I have 4. And sure enough, it does. So far, so good. Any questions about this? Really, there's a great video I posted this week that probably did a better job explaining it than I'm doing now. the differences between array and array list. And what it really illustrates is that everything you can do in an array, you can do in an array list, but you can do more, right? For example, I cannot remove an element in an array, or I can remove an element in an array list. I can't add an element in an array, but I can to an array list. But I can change values, I can access values, and so on. Now, this comes at a slight cost, tiny little cost. And that cost is that it has to be an array list of object references. So if I try to do this, I create an array list of ints, and I try to add an element to it. If I run it, it's going to blow up. I hope they're going to show me the error. There. All right. That's telling me that it requires a reference. It requires an object reference variable, not a primitive. So what does that mean? Does that mean we can never use integers and create an array list of integers? No, there's a way around it. And the way around it is through what's called boxing and unboxing. All right. For every primitive, there is an array version of the primitive. I'm sorry, not array version, an object reference version. And it's sort of like a wrapper around that primitive. So, for example, if I declare an int, that is a primitive. If I declare an integer, that is an object that contains an integer. All right. But Java does a nice thing, is for the most part, there's a little difficulty that comes in when you get into comparing, but for the most part, where you use an int, you can use an integer. So I can say y equals 1 plus 1. Then I can say x equals y, and then I can output the value of x. I forgot a semicolon. Thank you. Oh, I forgot to change that. We'll have to change that to an array list of integers. I want to change this to x. All right. So 1 plus 1 equals 2. This is actually a object reference, but I can still use it like an integer. So I can say y equals 1 plus 1. I don't have to use a set function or anything like that. I can just use it like a primitive. I can take the value of an integer with a capital I and assign it to an int. And it does sort of the conversion for you. I guess it's called a conversion. It does a conversion for you. It changes the type. All right. Finally, I can even add, you look at this, I'm adding an int to that array list, and it didn't complain. Why didn't it complain? Because I declared the array list for being to hold integers, And if I try to give it an int, it automatically converts it to an integer. That's called boxing and unboxing. You box something when you take a primitive and make a object out of it. You unbox it when you take the object and make a primitive from it. Yes. Right, even if we didn't do this? Yep. It will probably say 0 because int doesn't have a value. So int will get the default value, which is 0. Oh, the compiler actually warns me that it might not have been initialized. And it tells me that it's equal to 0. Can add it. All right. I might have been mistaken then when I was talking about default values before, because I thought that would make x a value of 0. I might be thinking of something else, and I apologize for that. All right. Now, how do we loop through an array list? There's a couple different ways. One is with a for loop. So we have our array list that contains strings. We add 4 strings to it. Then we have a for loop that says for I equals 0, I is less than cars.size, I plus plus, system.out.println cars get sub I. So what values will I take in this loop? What values will the variable I have in this loop? Right. So in this case, there's 4, so it would have 0, 1, 2, and 3. All right. Which nicely corresponds to this is the 0th element, this is element 1, this is element 2, and this is element 3. Each time it increments by 1, so it goes up 0, 1, 2, 3, not 0, 2, 4, 6, 8. It does it with the size, so if I change the size, I do not have to change the code. Because this variable now has the new size for this. Its size will be 3, and therefore this will be 0, 1, and 2. There's other ways that you can loop through. It's funny, I don't use this as often as I use the previous for next loop. Because I hate to sound like an old timer, but when I first started programming, I don't believe there was a for each loop. So I never really learned it initially. But it works just the same. I can say for each string I, cars, system out, println I. What that means is the first time through the loop, I is going to be set to cars.get 0. The second time is going to be set to cars.get 1. The third time, cars.get 2. And each time through the loop, I changes to point to the next value in that array list. And you print them out. This one for laughs. All right, let's see what we're missing. Let's see what other functions about an array list we're missing. There's different constructors. We cannot just add, but we can add a bunch of things at once with an add all. We can add at a specific place. All right. In other words, every time we did an add, by default, it adds it to the end of the list. What if we want to put it between 2 and 3? We could say add 2. All right. And it'll put it in position 2. Sorry about that. I don't care about my car's extended warranty. All right. You can ask if that particular object is contained in the array list. You can ask if the array list is empty. And so on. You can remove all, or you can clear. Both do about the same thing. All right, so there's a lot of things that you can do with an array list that you can't do with an array. The only one thing about an array list, sort of the catch, is if you want to put primitives in there, you got to box them. Got to use one of the boxes. And for every primitive, there's a object reference version of it. All right, now let's look at an example. In this example, I'm going to not just look at one pizza at a time, but we're going to look at multiple pizzas at a time. So here's my unit test. Here's my pizza object or class. Then I have added a class, which is the order class. Now, if you think about it logically, what is an order? Well, an order has some other attributes, right? It has a name, a phone number, an address if it's delivery, whatever. But essentially, other than a few other attributes, an order, when you call a pizza place, is simply a list of pizzas. All right? I want, small cheese, medium pepperoni, large with mushrooms, whatever. And how many can I have? Well, I can have as many as I want. Can I change my mind and get rid of one? Absolutely. All right? So, first thing I've done is I've created that order class, and I've given it a name and a phone number, because I figure, okay, at least you need that. I'm setting that in the constructor because what's an order without a name or a phone number? All right, who's it, could you imagine, I have an order, who's it for? I don't know. What's their phone number? I also don't know. Kind of useless. So I made strings for the name of the person and strings for the phone number. I have my sets and gets. Then I have a method to add to the pizzas array. I guess the one other thing I forgot to put in, or forgot to mention, is I have an array list that contains pizza objects. So we're not containing strings like we did in the other example. We're containing pizza objects. All right. So my array list that contains pizzas is called pizzas. And it's a new array list for pizza. And again, I can get rid of that if I want. If I want to add a pizza to the array, I call this method and give it a pizza. I then have calculate bake time, calculate price, and both of those kind of do the same. They loop through the array list, grab the next pizza, call the pizza's calculate bake time, and look to see if it's greater than the current bake time, it sets it to that pizza's bake time. So if you run through this, by the time we get to the end here, bake time is going to have the maximum of all the pizzas bake time. Now, notice that I don't have the calculation for bake time in the order. The order is simply a collection of pizzas. The bake time of a pizza is a function of a pizza. A pizza knows how long it takes to bake that kind of pizza. This is called encapsulation. You put everything related to a class in one place. So, same thing with price. All the order knows is I got these pizzas. I'm going to ask each pizza what its price is. I'm going to add that to the total and return the value. So we have a function for bake time, which is based on the crust, it's either 10 or 16. Then we have a size for the, or we have a value for the, depending on the size. Pepperoni adds $2. Otherwise, it's 8, 10, and 12. So let's look at our unit test. I'm creating a couple of pizzas. I then create my order, and I add those two pizza objects to my array list. How do I do that? By adding, oh, right here. Order O equals new order, Mike 4796. I add to that order the first pizza and the second pizza, and I get the total cost and the total bake time of the pizza. Let's run this and make sure we understand how it works. Okay, I'm in that folder. I do a directory listing, and I compile everything. I type in javac star.java, compile everything, gives me a clean compile. I then run the Java unit test. I hope you read my message about hard coding values, because some students get very confused about that. I'm only ever going to hard code values. Well, that's a big term. But for the most part, the hard coding happens in the test case, because I want to make sure that it works for this kind of pizza and that kind of pizza and that kind of pizza. So to guarantee that, I sort of stack the deck and create pieces of all the types that I want to test. So now I run this. It says that the pizza is small, the crust is thick, it does not have pepperoni. So the size is, oh, the bake time is 16 minutes, which remember, thick crust was 16 minutes, thin crust was 10. The second pizza size is large, thin crust, pepperoni false. The bake time is 10, and the price is 12. Does this match the calculations? Yes, it does. Because for a pizza, thick crust gets 16, thin crust gets 10. Pizzas are 8, 10, and 12. Unless they have pepperoni, then there's $1 more, or I'm sorry, $2 more. And thick crust is also $1 more. Oh, that's why this is $9 instead of $8, because that's thick crust. Now, I look at the order, I loop through them, and I get the cost of the order is $21. That's right. 12 plus 9 is 21. And the bake time of the order is 16 minutes. That's correct, right? Because if I had a 12-minute pizza or a 10-minute pizza and a 16-minute pizza, I put them both on the same time, they're not done until that second pizza is done. The one with the longer bake time is done. So the bake time for the whole order, assuming that the pizzas go in at the same time, is 16 minutes. Questions about any of that? Yes. Let's see. Let's see, when I create the pizza objects, I pass it a size and a crust type. Here I pass a size. So in this example, I actually have three constructors. One that accepts the size, the crust, whether it has pepperoni or not. One that accepts the size and crust and assumes that you don't have pepperoni. And finally, one that accepts only the size, and it sets the size but defaults the crust to thin and has pepperoni defaults. Be sure you understand this. Play with it. Play with the unit test to make sure that you get how this works. All right? Because this is really, really, really important, the way this works. This will be at the core of a lot of our upcoming homework assignments. I will give you one tip about the next homework assignment where you replace the attribute for credit hours with an array list. All right. You do not put an array list of students in the course class. You put an array list of courses in the students class because we're interested in holding all the courses for one student. And therefore, we're going to have an array list in the student class that contains courses. So that's sort of the tip. I know a lot, when I run this historically, sometimes students get confused between the two. And I can understand why, but for what we are doing, the array list goes in the student class. Are there any other questions? All right, we'll see you next week.